your monthly dose of astronomy news and views. This is Awesome Astronomy.
Hello and welcome to Awesome Astronomy, episode 12. I'm Paul, your host this month, and of course joining me is Ralph.
Hi there, Paul. If we can't do astronomy, let's talk astronomy.
Yeah, we have a packed show lined up, our monthly sky guide, discussion of the latest astronomy and space news, the search for ET in our 5-minute concept, an interview with an astronomy communicator, Mark Thompson, and of course our ever-popular question and answers. So Ralph, the last month has been a bit of a washout for me, but it started really well.
Yeah, it really did. We started off heading out looking for dark skies in Wales. We went into central Wales, into the Brecon Beacons, where we now hold the biannual Astro Camp, which is an opportunity for people, whether they're beginners or seasoned astronomers or astrophotographers, to all get together, to share some tips, to share the eyepiece, and really just have a fantastic time under some really, really dark skies.
And there was a real mix, wasn't there? We had people who were imaging with some really amazing kit, right down to guys who were pretty much opening their telescopes at the camp. Yeah,
and one of the things that I really noticed this time was how many people there were that came along that didn't have scopes themselves, or it had actually been the first time that they looked through a scope. So I thought that was wonderful, being able to share these views with some people, and everybody went away really, really happy. And I know later on we're going to be putting together some interviews that we recorded with people that went along to Astro Camp.
The atmosphere was fantastic. I mean, we, as well as looking at the skies, we had some talks. We had a quiz, a fantastic quiz, with some fantastic prizes where people walked away with a solar scope.
Yeah, well, that was one of the things that we wanted to do this time, to really give away some prizes that people could use right out of the box. And with it being solar maximum, it kind of made sense to give away a Hydrogen Alpha solar scope. But then, we also gave away a nice 127 Schmidt-Cassegrain, and, well, you say that there were some talks there, but I think you're being a bit humble there, Paul, because you gave a couple of fantastic talks.
I put something together, and of course Tom, good old Tom,
erstwhile
host of the show, he put together a couple of really great talks on the solar maximum and the aurora, and of course on Patrick Moore.
So we talked to a whole bunch of people that came along to Astro Camp, and as I said before, they were both seasoned astronomers and absolute beginners, and we interviewed them for their views on this unique brand of star party.
What would you say is the best thing about star parties?
I think there's a couple of things. The first one is obviously just the amazingly dark skies. The fact that you can just see the Milky Way arcing across the sky. And
I think the thing I like best is there's so many people there with so much experience who are all really friendly and keen to share their expertise and their eyepieces and everything with everyone else.
The best way of seeing objects in the sky I can't see in the centre of London, where we are at the moment. What can we see? Very little at the moment. But if we go to a dark sky site at star parties, we see things I can't see here. Galaxies and nebula, which are a no-no in central London.
Probably just lots of different views you could see through loads of different telescopes. So you could see through smaller telescopes and larger telescopes, and the difference was really good.
Well, I like sharing my scope with people. I can sit at home in the back garden for hours on end by myself and not see anybody and just look at objects that I like. But I like to share the night sky and the telescope with people, and it's a good way of doing it.
and then actually just hanging out with a load of like-minded astronomers as well is actually just makes it a lot of fun.
The ripple of excitement when someone finds Jupiter, and then everyone starts pointing at Jupiter, and then when Saturn comes up, and then later on going around and seeing the different things people are looking at through their scopes.
I think the variety of equipment that's there, you get a wide range of people coming, which means you get to pick and choose what telescope you look through. You know, being able to go to Astro Camp allowed me to look through a C11, a 12.5-inch Dobsonian telescope. It's just fantastic.
What would you say was the object that you most remember from Astro Camp?
Well, I spent an awful lot of time just in the sort of the Leo-Virgo galaxy cluster, and obviously started with the Leo triplet and was actually able to spot all three components, which is pretty good for a 4-inch telescope.
Can I say Andromeda again?
M13.
I think I'd go for M13.
I think it was M13 through our scope. I really enjoyed looking at that.
There's, you know, the double cluster and the beehive cluster are both visible naked eye as hazy patches, and these are just things you don't see in London.
There were several things that I saw at Astro Camp that I really wanted to get hold of. Lots of things in Virgo and the Hercules cluster, but my favourite was the Ring Nebula.
First things I've seen ever in my life were the Leo triplet. Well, 2 out of the Leo triplet. And the Whirlpool Galaxy. Never seen those before. Saw them at the Star Party in Wales.
and then basically just went for a meander through the galaxy clusters. And to be honest, I couldn't tell you which ones I was looking at half the time because there's just so many of them. But it was pretty cool.
Probably actually not one object, but three. The Leo triplet, absolutely fantastic. Can't really see it that clearly from London because of the light pollution, but under the dark skies at Cumdy, absolutely fantastic.
And then we saw Comet's Pan-Star, so we'd missed it because it was behind the trees at the bottom of our garden. But we saw it at Astro Camp, and that was great.
What would be the abiding memory of the Astro Camp?
Well, you may find this a bit funny, but it was a superb black pudding at breakfast at the Farmer's Arms. Highly recommended.
I think the pub quiz was great.
I think being amongst a group of people that share the same interests is just fantastic. It helps you develop your own skills amazingly.
The whole atmosphere, and also actually seeing the sun through people's scopes as well. So it wasn't just nighttime, it was daytime as well.
Seeing other people's scopes was fantastic because I never get a chance to see other people's normally.
Probably the solar flare that we saw, which had the smiley face. I thought that was really, really good.
There was a really, really good atmosphere on the field. I think, especially on the Sunday night when we had 30, 40 telescopes all within a small area and everyone was just walking around looking through each other's telescopes. That was awesome. That was really good. And I'm really looking forward to the next one.
I think actually the solar viewing during the day was probably one of my favourite things.
And getting to know lots of people with the same interests. It was a great time.
And the quizzes were good.
To be honest, it's not so much astronomy. It was a lot of fun.
The amazing weather. I mean, I'm expecting that it's going to be amazing weather again for the next Astro Camp because on the strength of the last two, the only weekend without rain and overcast skies and everything. That's got to be part of the Astro Camp guarantee, right?
And finally, will you come again?
Yes.
Yeah, definitely.
Absolutely.
Would I come again? I think so, definitely.
Absolutely. It was great fun.
I would, yes.
Oh, definitely, yeah. You struggle to keep me away, I think. I'm definitely always going to be clearing my calendar in sort of May and September every year from now on.
It was a great weekend. I was very pleased with my own personal tally in Wales. Objects I've never seen, and seeing M13 in scopes of all sizes was incredible. Mm-hmm. A stunning wide-field view in beautiful 60mm Takashi, then right up through the apertures to a full-colour view that was up close and personal in a 12-inch Dobsonian. Really stunning views, and I think lots of people shared that, and that was one of the great moments of the camp, something I won't forget. Can't wait for September.
This is Awesome Astronomy.
Well, that was May, so now to look forward to the new month, June, and what the skies have to offer with our Sky Guide. Well, June is in many respects the worst month for traditional astronomy. We have the summer solstice at the end of the month, where the sun will reach its highest point in the sky, and dark skies last no more than a couple of hours in the UK, so I will say that first, as we are in the solar maximum, it's probably the best time to get out and enjoy some solar astronomy. The sun is high, it's up for most of the day, and the weather should be at least warm. The warning, of course, do take all the necessary precautions when looking at the sun. Don't look directly with naked eyes, certainly don't look through an unprotected, unfiltered scope or binoculars, and if in doubt, do get advice. What you will see, though, depends on what you are using. If you're using white light filters, then sunspots and some granulation should be visible, while if you're filtering with hydrogen alpha, then prominences and filaments, as well as plage, all come into view. In both cases, look out for the phenomenon of limb darkening, where the sun appears to get darker the closer you look towards the edge as you see it. I saw some fantastic imaging done recently at AstroCamp.
Yeah, absolutely. The images that really stood out for me were the ones that were done by Damien Phillips. And if you go onto Flickr or Twitter, he'll be down there as Dephelis, D-E-P-H-E-L-I-S.
That's right, yeah.
And it was just using border solar film, which you can buy for £25. But the amount of detail that it was getting in the penumbral regions of the sunspots, just absolutely fantastic.
Incredible.
So they really are worth taking a look at.
So, next, onto the moon. This is another target that is not affected so much by the light skies, so for those of you who spend most of the year hunting deep sky and cursing our satellite, then this might be the time to go out and have a look at your foe. It's a shame it gets ignored. I think the moon is seen as a bit passé by some astronomers, but there are some breathtaking things to find on the surface. If you catch the early 2-3 day old moon on the 10th, 11th, you can enjoy one of my favourite areas, the Mare Crisium, the Sea of Crisis. And further south, spectacular crater Petavius with its terracines and distinctive-looking rill running through it. Later on, around day 7-8 on the 15th, 16th, look out for the Vallis Alps, a 130-kilometre rift valley cut through the lunar Alps, which is a very spectacular sight. Day 9 sees my favourite lunar object, crater Copernicus. Has to be seen to be believed, a vast terraced crater, almost 4 kilometres deep and 93 kilometres across. A city such as Chicago or London would be lost inside it. When we reach full moon on the 23rd, we're in for one of the biggest full moons of the year, as it coincides with perigee, when the moon on its elliptical orbit is closest to Earth. Of course, the media will be full of supermoon stories. The difference is observable, especially if you're a close watcher of the moon, but it's not that great. But it will look a great full moon.
Yeah.
Right, planets are a bit thin on the ground this month. Uranus, Neptune and Mars are crawling from under the sun's glare in the early hours by the end of the month, but will not be that great to look at, and of course Jupiter is essentially lost to the murk of sunset. But 3 planets are visible, Venus and Mercury, which will be in conjunction for the first half of the month. They'll be low down, about 6 degrees in the northwest in the constellation Gemini after sunset. While Saturn is sitting in the constellation Virgo and should be an easy find and always worth a look through a scope. Look out for the moon on the 18th and 19th as it will pass by the star Spica and Saturn and hopefully make a very nice formation in the low southwestern sky.
And that's the kind of view that we got to see just last night. We're recording this on the 22nd of May. And we got to see a very similar sight of that. And when you've got the star, the planet, and the moon very close together, it really is quite a striking sight in the sky.
And the Spica and Saturn are sort of easily confused, the two of them. They sort of look very, very similar in colour, in fact. Moving on to the small dark window of dark sky, I've selected 4 deep sky objects. M13, the Great Globular Cluster in Hercules, is one of the sky's must-see objects, and it's worth a comparison with nearby M92. A globular I'm a fan of, but it often gets overlooked. Lyra is also back in our skies, and that means M57, the Ring Nebula. It's easy to find, and that sits between the stars Beta and Gamma Lyra. Staying in that constellation, it's also worth locating Epsilon Lyra, which is near Vega. First, take a look with low power, and you'll see it as what looks like a double star, then rack up the magnification, and, well, you'll see why it's called the double-double.
That is just such a beautiful sight. Got to be one of my favourite objects in the night sky.
I was looking at it last night, actually. Very difficult transparency conditions, but it was definitely worth it. Definitely worth it. One further object to mention is the International Space Station, which Ralph is going to talk a little bit more about in the news. June will be a good month for ISS passes, with 2 or 3 passes a night from the beginning of the month until the 20th. Passes in the UK tend to rise in the west to the southwest and pass overhead to the east. Magnitudes can be very bright, often outshining Venus.
This is Awesome Astronomy.
Well, that's our guide of what to look out for in June, and now it's over to Ralph for the latest news, and I believe your first story is not a happy one, Ralph.
Yeah, that's right. It looks like the end might well be nigh for one of NASA's greatest observatories. And I don't know about you, Paul, but for me, the Kepler Space Telescope is the greatest ever spacecraft.
Quite possibly. I think even if this news is true, Kepler will be right up there with the Voyagers, Kobe, Hubble, Herschel, that pantheon of great astronomy satellites. What it's told us might well give it top billing.
Yeah, I didn't know if you'd agree with me there, but the reason I think Kepler takes the top spot is because it shows, well, NASA at its finest, pushing the boundaries, being daring and being speculative, because when it was launched back in 2009, we just had no idea that the galaxy was actually littered with individual solar systems. Back then we had indications of 314 planets possibly existing around other stars, and not all confirmed. Most were suspected from ground-based inferences, but Kepler revolutionized this by scanning around 160,000 stars to start with, and showing that about 8,000 of those were variable stars, and therefore unsuitable for exoplanet hunting. And that's a finding that also had value to other planetary hunts using the transit method, but it also confirmed that a previously suspected planet was really there, and then went on to discover 2,740 more exoplanet candidates as of May 2013, when it looks like, unfortunately, we're coming to the end of the road for Kepler. And this is particularly sad, I think, because last year Kepler had a mission extension to 2016, the mission duration it needed in order to satisfy its goals of determining what fraction of stars might be capable of harbouring life, or more simply put, how many stars have Earth-sized planets in the Goldilocks zones that Paul's going to be mentioning shortly. And since January, the spacecraft, well, it's been ailing. There was a reaction wheel fault earlier in the year which caused some dismay because Kepler needs 3 of these reaction wheels to be working to keep it precisely pointed at its target stars in the constellations of Lyra and Cygnus. And at the time it looked like friction was building up on the problematic wheel, but NASA were able to get it functioning again. But this time, a combination of reaction wheel and thrusters were needed until just a few days ago to maintain the spacecraft's steady gaze, and using thrusters in this way would have exhausted the onboard fuel supply in just a matter of weeks. So, the team have now put it into what's called a point rest state safe mode, which doesn't burn up as much fuel and gives them more time to diagnose the fault and try and work out a way to extend its operations for as long as possible. but unless that reaction wheel miraculously starts functioning properly again, we just have a few months of extra data gathering, and then we're only left with the data already collected. So I'm sorry to start with a downer, but it also goes to show that space exploration isn't as easy as NASA often makes it look. Not everything that NASA does has the automatic right to perform years longer than they're designed to do.
Very sad, really. There must be some pretty glum faces over at NASA right now. So something more cheery now, I hope.
Yes, alcohol in space.
Oh, get in.
Chin chin. So this is a story that cropped up in the new year, but it kept getting bumped back because of big news stories that kept popping up, but it shall be relegated no more. And I think you'll like this story, Paul, because it's not just astronomy and cosmology, it's also a time-travelling fundamental physics experiment from astronomers at the VA University in Amsterdam and the Max Planck Institute in Bonn. And they've used the 100-metre radio telescope in Effelsberg to take absorption line measurements in methanol at known frequencies. Methanol, that's where the alcohol comes in. And this was to allow them to see the mass ratio of protons to electrons in a galaxy some 7 billion light-years away. And put simply, that means they've looked back in time 7 billion years and shown that, with a high degree of certainty, the ratio of the mass of protons to the mass of electrons was the same as we observe it today. Now, this doesn't sound too exciting, except for the fact that they used space alcohol to detect this, but like knowing the speed of light or the force of gravity was the same billions of years ago, without demonstrating it, we're taking a guess whenever we do models or computer simulations of events in the universe's past based on the forces and constants that we see today. So this finding means that we can have more confidence in our theories of the evolution of distant galaxies or the birth of first and second generation stars, for example. And Julia Bagdanate from the VA University puts it like this. The methanol molecule had absorbed these radio waves 7 billion years ago, and the waves have carried along its fingerprint from the distant past on their voyage to Earth. And I think that's a beautiful way of putting it, and the next step now is to find even more distant galaxies suitable for this kind of study with methanol in them to repeat the experiment. But for now, they're confident saying that the mass ratio of protons to electrons is another universal constant that hasn't changed over billions of years.
I find it incredible what research is taking place on the cosmos and what you can actually evidence at the moment. I love the idea of astronomers searching for alcohol with a 100-metre radio telescope. It's just brilliant. So what's next? Can you top booze in space?
Nobody can top booze in space, Paul. That's another universal law. But we can talk about the most violent explosions in space.
Oh, that sounds good.
Okay, well, anyone that's been galaxy hunting in Leo recently, or just admiring that huge lion shape of the constellation in the sky this time of year, couldn't have been aware of one of the universe's most violent outbursts that was emanating from that part of the sky last month, because not only was there a gamma ray burst, but the detectors on the Fermi and Swift satellites suggest that it was the biggest gamma ray burst yet seen. So, for a bit of background, military satellites in the 1960s that were designed to detect any Soviet nuclear tests picked up random gamma ray sources that on further inspection appeared to originate in space. Now, gamma rays are at the far extreme end of the electromagnetic spectrum beyond X-rays, and like X-rays, they're blocked entirely by the Earth's atmosphere and can't be seen with human eyes, though associated optical light often accompanies gamma ray bursts. Now, we see far less than just 1% of the total electromagnetic spectrum, and gamma rays are the most energetic. In fact, if the atmosphere didn't protect you, they'd stream right through your body all the time, destroying your DNA.
Nice.
So, where do they come from? Well, the most common causes are supernova explosions when large suns run out of fuel, or when two stars collide, and in this case, astronomers are now waiting for the glow to subside to see if a supernova remnant has been left behind. So, for perspective on just how much brighter than a supernova remnant this energy burst was, it's shining 400 times brighter than an entire galaxy that can be seen at the same distance in the same field of view of the 8-metre Gemini observatories. But luckily, at 3.6 billion light-years away, this gamma ray burst isn't going to cause any problems, even though it is one of the closest of these bursts we've ever witnessed. If something like this happened in our own galactic neighbourhood, and the gamma ray jets were pointing at Earth, it'd be game over. Not even Bruce Willis could help us. And now, a similar explosion from a star as close as Alkaid, the familiar star in the Handle of the Plough, it'd fry us all if it was just a bit more massive and about to run out of fuel, and its gamma ray jets pointed towards the Earth. And about now, you might be starting to think, hold on, this contains a lot of ifs. And you'd be right. Although gamma ray bursts are one of the most destructive forces in the universe, there aren't any candidate stars close enough to our solar system, and near enough to the ends of their life to cause us any worry. But these distant gamma ray bursts can tell us a lot about stellar death and black hole or neutron star formation. So when the Swift and Fermi satellites detect them, astronomers around the world get excited, and all eyes, or scopes, rush off to collect as much data about these mysterious events as they can.
Okay then, so now something close to home. Congratulations must first go out to Tim Peake, Britain's first astronaut on the European Space Agency's astronaut corps, who just heard that he's been selected for a long-duration International Space Station mission in 2015, which of course we'll cover more of in the future, but in the meantime, the ISS has been headline news.
Yeah, congratulations to Tim, and we also have to say a big well done to Canadian astronaut Chris Hadfield, who's entertained, educated, and connected with the public back on Earth in a way that possibly no other astronaut's ever done. Chris successfully completed his 6-month expedition to the International Space Station on the 13th of May, when he touched down after being the first Canadian to command the orbiting spaceship. And it's perhaps fair to say that there are a few technological advances that have made his incredible outreach possible too, like the International Space Station now having a 10 meg internet connection and that 10-foot wide cupola or window that was installed in 2010 to give stunning views and photographic opportunities of the Earth, things that previous astronauts just haven't had at their disposal in the past. But more than anything, it gave every aspiring astronaut their best glimpse of what life's really like on board the International Space Station during his time as the ISS's commander by flooding social media with tweets and interviews, images and songs that reverberated around the internet and happily clogged up everyone's Twitter timeline. I don't know about you, Paul, but almost every hour I could have seen a Chris Hadfield tweet that had been retweeted by someone that I follow.
I was guilty of that.
And they were an absolute pleasure to see, whether it was a picture of the Mongolian highlands or updates on sensations and medical conditions or being interviewed by William Shatner. His time on the space station, despite not even being a NASA employee, has perhaps been NASA's greatest PR opportunity since Sally Ride became the first American woman in space back in 1983. And if you've somehow managed to miss all this vicarious astronautery, just go on Twitter and look at every tweet that Chris Hadfield's made over the past few months by typing @CMDR_Hadfield into Twitter or type in Chris Hadfield into YouTube, and you'll be engrossed for hours. The images are breathtaking, and having a commentary of a serving International Space Station commander was just amazing. We had almost daily videos showing us, what happens to tears in space, how water clings to your hands if you wring out a hand towel, how eyesight's affected, and the difficulties of clipping your nails in microgravity. And you can see the germ of these informational clips in the videos he took when he was on a deep-sea expedition, and he shook up a soda can at 2.5 atmospheres under the ocean before opening it without the coke going everywhere. And there aren't many people that have played backing guitar with a live band from the International Space Station, and his rendition of David Bowie's Space Oddity just before he left the ISS, which should have sounded like an awful karaoke, was, brilliant. And if you think about it, what's more rock and roll than space? Rock and roll and the space program were born and grew up together, whether it's Bill Haley's Comets, Pink Floyd's Dark Side of the Moon, Apollo spacesuits on a Led Zeppelin album cover, The Police walking on the moon, or Babylon Zoo's Spaceman. Actually, no, forget that last one.
God, yeah.
But Chris Hadfield just carried on that rock and roll and space connection. So congratulations to Tim Peake and Commander Hadfield. Thank you, and we salute you.
Though I've flown 100,000 miles, I'm feeling very still. And before too long, I know it's time to go. Our commander comes down back to Earth and knows. Ground control to Major Tom, the time is near. There's not too long. Can you hear me, Major Tom? Can you hear me, Major Tom?
Well, from one space oddity to another in this month's 5-minute concept, where we ask the same question Enrico Fermi posed about the cosmos. Where is everybody? Okay, the area inland from Orford Ness on the Suffolk coast has an interesting history. Due to its pleasant climate and habitability, there are Bronze Age settlements, there's the Sutton Hoo Saxon burial, the site of a fabulous royal treasure, and the body of a mysterious king. It was the area where military aircraft were tested in secret in the 1930s and 40s, while post-war it was where the Post Office and subsequently BT set up their classified research and test facility. In December 1980, though, it was the place where American airmen from nearby US Air Force bases witnessed the arrival of a craft from another world. Except they didn't. On 3 consecutive nights, they roamed Rendlesham Forest, chasing the light of 2 nearby lighthouses, Venus, and even a well-recorded fireball that fell over England. In the ancient and mysterious landscape of the Suffolk coast, under the pressures of the Cold War, a group of men far from home were caught in a delusion that aliens had visited Earth. Aliens. Life on other planets. It's a subject that captures the imagination and it fires debate. It's perhaps the most fundamental question of all: are we alone? much of the public debate focuses on the idea of intelligent beings like us, civilizations capable of speaking and sharing with us, or in darker moments exploring our fundamentals. But if the story of cosmology in the 20th century has told us anything, it has demonstrated the vastness of the universe, that the distances involved are eye-wateringly far and appear to preclude any sort of fast travel between star systems. So, within science, the search for life takes three distinct strands: the search for signals, the search for habitable planetary systems, and the search within our own solar system. The first is most famously seen in the SETI project, the search for extraterrestrial intelligence, a privately funded listening exercise pointing antenna at the sky and listening for telltale signals that differ from the normal background noise of the cosmos. The theory goes that if Earth is broadcasting a range of signals that demonstrate our existence, why not listen out for others? We especially listen on so-called special frequencies, such as the frequency of hydrogen multiplied by pi. Such a peculiar and precise signal would surely demonstrate intelligent life. It's a big sky, and so far all we have to show for this search is one isolated blip labelled WOW, most likely the cosmic equivalent of the Orford Ness Lighthouse. The second strand, the search for planets, has been one of the great success stories of astronomy in the last 2 decades, spurred on by incredible leaps in telescope and imaging technology, and craft such as Kepler. In of itself, the search for exoplanets, of which there are now over 893 confirmed, is not a search for life. But key to the project is a search for an Earth analogy, a planet like our own with the habitable zone of a star. The habitable zone, the Goldilocks zone, the circular area around a star where water in right conditions can exist at the triple point and be liquid, solid and gas. The Sun has such a zone that stretches from the orbit of Venus to the orbit of Mars, a zone which, of course, we sit in the centre of. Based on our own experience, and let's face it, Earth is the only experience of life we have, planets that sit in this zone have become a popular focus of exoplanet hunting. But at present, it is a hunt based mainly in the imagination. Most planets we have found have so far been close to their star. This is mainly due to selection criteria. Kepler is only 4 years into its mission, and might not go any further, and needs 3 signals to establish an exoplanet, which means 3 orbits around a star in less than 4 years. We've found planets in habitable zones, but what that means for these planets we can only guess at. Any speculation in the media, while fun, is more fireballs and lighthouses. It won't always be so. With bigger and better telescopes on the horizon, such as the James Webb and Echo, we are on the verge of looking into the atmospheres of these far-off worlds. Of course, not directly, no scope will ever be capable of that, but the light of parent stars will pass through the atmospheres, and with it the light will bring the chemical fingerprints of those atmospheres. What will be a sign of life? Well, based on what we know, oxygen might be a good start, but the O2 you and I breathe provides a very weak signal in this sort of exercise, almost impossible to detect. But O3, ozone, is far more detectable, so we will look for that. How will finding ozone on an exoplanet point to life? Well, Earth has O3 because it's teeming with life, most importantly plants replenishing the supply of oxygen. If life on Earth ended tomorrow, the oxygen would quickly combine, as it already does, with other chemicals, and without replenishment would all but vanish from the atmosphere, ozone included. No source of replenishment, no ozone. Of course, the proof would never be concrete, but ozone would be a good marker of life. Methane is another, gas that some observations suggest is present close to home on Mars. Our own solar system contains life, but so far we've only found it in one place. We have been looking, not particularly hard, but so far a blank. Of course, we're not talking about little green men or Venusians, but probably microbes and bacteria, simple life, unicellular. The search is widening all the time. On Earth we have found that life has a curious way of popping up in places we previously thought impossible. It's happening so often now that science is getting flipped on its head, and life itself probably started around these thermal vents and in embedded rock-like structures. It's us on the surface with all the radiation and corrosive gas that should be viewed as the extremophiles. How will we know when we find it? Apart from the obvious, movement, respiration, reproduction, etc., we might find that the signs are subtle. Process structure, concentration of chemicals, a preponderance of one type or version of a molecule, fragments of sugars and carbohydrates or DNA. Nothing at present is actually looking for these things, and we're a long way off from fishing expeditions to the moons of Jupiter. Which leads us back to Suffolk. We may pour scorn on the tales of midnight UFO hunts and conspiracy theories, but in many ways science itself is no closer to proving that some of the lights in the sky may be life. At the moment, we are just chasing lighthouses in the dark. Aliens, Ralph. What do you reckon?
Well, the American government will never let you know the truth. Just look what happened to poor Tom when he found out about life on Mars. Curiosity zapped him with its lasers, and now he's no longer here to record.
Oh, I warned him about that laser.
Yeah. But being serious about this, it's such a difficult thing because we're extrapolating from a sample size of one. We only know about life existing in one place, and that's on Earth. So taking it any further is just entirely futile. What we do know is that the universe is absolutely huge. We know that the galaxy itself is absolutely huge, and that it's littered with water. There's amino acids and there's proteins everywhere. So I think there's likely to be microbial life, and I think there's probably microbial life all over the solar system. But making the jump from single to multicellular life, I think that's the difficult thing. And of course, we've still got to find it.
Yeah, and of course, I mean, multicellular life took billions of years to get going on Earth. I mean,
that's right.
Unicellular life was around for a while, and multicellular life is a very recent innovation, sort of comparatively. So
it seems to me that there's these two stages in evolution where it almost seems unlikely to happen in the extreme, but luckily on Earth it has done, and that's the jump from microbial life to multicellular life, and then the jump from animals into intelligent, sentient, self-aware beings.
Yeah, profound.
This is Awesome Astronomy.
Okay, that's aliens done with. So it's now over to Ralph for this month's interview with amateur astronomer, writer and broadcaster Mark Thompson.
Mark Thompson is an amateur astronomer, TV and radio presenter on the BBC's The One Show, Alan Titchmarsh Show, Stargazing Live and radio. He's a writer and a committed astronomy educator, president of Norwich Astronomical Society and supports Norwich City Football Club, but we won't hold that against him. Mark, welcome to Awesome Astronomy.
I was about to unplug then, but yes, hi, nice to speak to you.
Well, people listening to this show will probably know you best from the Stargazing Live programme. Now, this programme attracts millions of non-practicing astronomers, so you must be very proud and excited to be able to introduce practical astronomy to such a large audience.
Yeah, it's been great. I mean, my sort of TV career, I suppose, is sort of focused on people who are not necessarily into astronomy. It's been working on The One Show and on the Alan Titchmarsh Show, which are both audiences which don't expect to see astronomy and science suddenly pop up on their screen. And certainly with Stargazing Live, it takes those people who've got the innate interest in the night sky and just takes them that extra step further. And I think for a long while there's been a lack of a show to cover those people. We've got, of course, got the Sky at Night, which is brilliant for the amateur astronomy community, but there was really nothing that actually went that little step further for the complete beginner. And yeah, it's great to work on Stargazing Live and to get out there, and it seems to be just a wonderful formula.
And how easy do you find it to bring people along on an astronomy journey that have never experienced it before?
It's quite easy when you've got people who've got the interest in the subject. Then it's not a difficult thing. It's when you're trying to educate kids or people who just don't have an interest in the subject. That's where the real challenge lies. But when you've got people who actually want to be taken along on that journey, then it's actually quite easy. Of course, one of the real challenges, particularly with Stargazing Live, is to actually include a bit of Stargazing Live.
Yes.
We've had luck a few times over the first three series that we've done now, where we have had clear skies, at least at some point during the 3 nights. But we're trying to package it up as an experience for people where they get to see a bit of live observing and experience that with the presenters. But of course, we are so reliant on the British weather, and that's the real challenge in it all.
And last time around, we saw you working with the academics from the University of Derby to recreate Herschel's 20-foot telescope in the last series. So, how much fun was that?
It was challenging. I mean, it was quite a wacky thing. We had, because one of the big joys of working on Stargazing Live is the way it involves people. Of course, last year we did the switch off of lights in Dulverton, which was fantastic, involving all of the local community to get that involved. So it was a real struggle to come up with something that we could do to involve people again and in a different and in a bigger way. So this idea was kicked around about recreating something like Herschel's telescope. We actually thought about getting the community involved in the actual build as well, but of course that was just going to be so limiting by way of having the right skill sets and also the safety of the thing. So we decided it's probably actually better just to get people involved by way of using it in the future. And so we got proper contractors in who actually helped us build the thing. And it was incredible fun. The people of Derby really did buy into the whole concept. Whether they'll use it, of course, now or not, I don't know. I don't know if they've had the weather or not to use it. It was a little bit cumbersome. Of course, Herschel's telescope was really originally designed to survey the sky. It was never designed with the idea of being able to point it at objects. So he didn't really use it to look at things. He used it to survey the sky. So it pointed it in one direction and let the Earth spin. And as the Earth spin, then of course it would sweep out across the sky, and he used that to discover stuff. So actually using this telescope to point at things. We originally wanted to point at Uranus during the live show, and of course trying to be able to point a telescope, which was really quite cumbersome to point accurately within a very, very narrow field of view at a particular object at a particular point in time of our filming schedule, was actually really scary and actually quite fun at the same time.
And I imagine Uranus would have been quite low down on the horizon at that time of year as well.
Yeah, I mean, it was low down. It was only just a few degrees higher than the minimum altitude that telescope could point at. So it was designed to help us point at, to make sure we could get there, but there were just far too many variables, and we had to use like a crowbar to sort of jimmy the thing around in azimuth. So, trying to get it to point within a few arc minutes, even within a few degrees would have been, one hell of a challenge. But we managed to do it. I was just quite pleased that we decided to drop that part from the live show, because that would just been far too much stress for me, I think.
And it was just so unfortunate that the weather prevented you from using it on the show, or for showing views of it on the show. And that's something that most astronomers will sympathise with. But did you manage to actually get a clear night's view through it before or afterwards?
I didn't actually get to look through the thing, which was really frustrating after all that. I mean, we had different people working on it. It wasn't me just down there with my screwdrivers building the thing. I had a big team of people working on it, and we had other people. We had some camera crews down there, a couple of whom were amateur astronomers as well, so they knew what they were doing. So we had a few people down over a few, night times. The nights I was there, it wasn't clear, which was really frustrating. But a couple of the guys did manage to get some clear spells where they did get to see some stuff. And of course, you saw some of the footage that we used on Stargazing Live, where we picked up a few objects, and it was just a real relief to actually get some footage that we could see through that telescope. And it did kind of not bring a lump to my throat, but it was just quite an incredible journey to have recreated something that Herschel did. Made me realise just how amazing a task it was that he completed.
Yeah, especially with the technology they had back in those days as well.
Absolutely.
That Herschel forged himself.
No, absolutely. I mean, just the mirror. We could, I have made a mirror myself. I made a 6-inch mirror back in the days when I was a young lad, and I know how hard that was to make mirrors of that scale. That in itself is amazing. Because we could just say to the supplier, can you go off and make a mirror for us? And we could get engineers, and we could get computers and calculators and all these things that we can use to work stuff out. He had none of that, of course. So it was an incredible achievement.
And you said there that you were excited about astronomy from a young age. So what was it that first got you hooked?
It was actually looking at Saturn. Perversely, my father was the one who had the interest in astronomy. I was about 10 years old. He dragged me, I don't know if I was kicking and screaming, but he dragged me along to the Norwich Astronomical Society near where I lived, to an open night where Saturn was on view. And I saw Saturn for the first time through there. I think it was a 10-inch reflecting telescope. And, it was just one of those sights that just completely blew me away. And even now I can almost still see it in my mind's eye, the rings around the planet. I think I can even recall seeing the Cassini division. Of course, I wouldn't know what it was then, but I think I can recall that kind of level of detail, against the velvet black sky. And it was just absolutely stunning. And even though I've seen some wonderful pictures back from the likes of Voyager and Hubble Space Telescope, they're nothing compared to seeing it for myself. And that it was that first view of Saturn that just set me off on this journey.
Yeah, I think it's knowing that you're seeing it live, and even today with the advances in telescope technologies and lenses that you can get now, people are still blown away by that first image of Saturn.
Absolutely. I mean, I've shown countless people, children and adults alike, the views through telescopes, and planets, particularly Saturn and Jupiter, never fail to amaze people. And even now, a lot of what I do is imaging based rather than looking through a telescope. I still do, take the camera out and put the eyepiece in and just enjoy it. And it is the most amazing experience.
Yeah. And for any of our younger listeners that would like to forge a career in promoting astronomy themselves, how did you go about getting into a career in promoting astronomy?
It was actually quite a perverse route for me. I mean, I've worked for most of my life. I mean, I'm now this year turning 40. Would you believe? I'm sure you're about to say that I don't look it. That's very kind of you. Thank you. So I've done this for a lot of years. I've done astronomy for a lot of years, and actually spent most of my working life in working with IT, working in project management. I even trained for about a year to be an airline pilot, but I just wasn't in the market at the right time. This was just after the 9/11 incident, and there was about a gazillion pilots on the market, so I didn't have a hope of getting any work. So I did a lot of work with my local astronomy society. I did a lot of work with lecturing. I started to get involved with the local media and did lots of radio work, lots of TV work with the local BBC and other local stations. And to be honest, it was just about getting known, and it was just almost by luck, by chance, that the BBC came along to a star party at Kelling Heath in April, a few years back now. And I did some work on the Sky at Night, and I did some work on the Culture Show. And through all of that, someone saw me and said, actually, would you be interested in doing some films for the One Show? And this was during the International Year of Astronomy, so I did 4 films for the One Show during that year, and that got me started, and it got my name around, and I haven't looked back since. So it really was. There was a lot of hard work in as much as I volunteered a lot of my spare time to get involved with local media, and eventually, if you put the work in, sometimes if you're lucky, it actually does pay off.
And with that experience that you've got of promoting astronomy, what do you think is the best way to get people, or to get interested people involved in practical astronomy and engage those that perhaps didn't know that astronomy could be so engaging?
I think, for those who are not sure that they're interested in astronomy, I guess it's a difficult one. But I think, show them through a telescope. Don't show them galaxies and star clusters unless you've got, I don't know, something like the Hubble Space Telescope, because I find them interesting and they are fascinating. But to a beginner or to somebody who's not really that interested necessarily, seeing a faint fuzzy blob is not going to inspire them. Seeing a planet or the moon will absolutely inspire them. So I think, pick out the big bright objects that people can see without any great effort. I think that's a really important thing to try and get newcomers involved. But I think people who are interested, then the next best step is to go to your local astronomy societies, and there are hundreds of decent astronomy societies up and down the country that, and I've visited loads of them, and I know most of them will absolutely, if not all of them, will welcome newcomers with open arms. So that that is absolutely the next best thing, is to get along to your local astronomy society, and from there you can look at different telescopes that are available. You can see what books and magazines you can get hold of and all that kind of stuff. And you can start yourself off on a journey. And of course, another good thing is apps. You can get loads of brilliant apps for smartphones as well now, which show you what you can see in the sky. So it's so easy to get involved in astronomy these days, which is absolutely wonderful.
Oh, you've mentioned apps there, but you're also a very active user of Twitter, and people know you on there as People's Astro.
That's right, yes. Copiously an active user of Twitter.
So how crucial do you see the role of social media in gaining public interest and communicating astronomy content?
I think it's incredibly useful. I mean, I've been using Twitter now for, I don't know, 2 or 3 years maybe, and I don't just use it for astronomy, and I use it to keep up to date with the news. I mean, I can't remember the last time I actually picked up a newspaper, so I think it's bite-sized chunks of information. I mean, certainly I would love to sit down and read an article about a new discovery, but for a lot of people, they're just actually interested in just a few words to know what's happened. So I think the sort of the bite-sized chunks of information that Twitter and other social media sites can give is incredibly useful for just drip feeding stuff out there to the public, and those that want to can just suck it up. And I think Twitter is a fantastic tool for that. Yeah,
and you must be excited now also to have a new astronomy book out called A Down to the Earth Guide to the Cosmos. So can you tell us how we can get our hands on a copy and give us an idea of what it's about?
Yes, certainly. I mean, the idea came about after doing the work on the One Show and Stargazing Live, where it's all about trying to find a different way of engaging with people, and finding other ways that you could try and get astronomy out to people that perhaps was a slightly different way than usual. So what we did is the book's actually been put together with 12 chapters covering each month of the year, and then what each chapter does, it kind of covers a narrative like the life cycle of stars or the evolution of galaxies or the end of the universe. And then what it does is it picks objects that are visible in the sky that month to kind of add a bit of colour to that story. So, for example, if I'm talking about the life cycle of stars, then it will show you what you can see in that month in the sky, amongst other things, but what things you can see that actually explain how stars live. So you can see for yourself how the science actually gets brought together. And that seems to work really well, and it's written so that you can pick it up anywhere in the entire world, and based on finding the celestial equator from your location, you can start finding your way around the sky. At least that's the concept of it, and from what I've read from the reviews, it seems to be doing really, really well, and it's very popular. So it's out there now in, I'll say, all good bookshops. It's not in the bad bookshops because they're the ones who don't sell it. But of course, it's also out there on Amazon as well, so there's plenty of places you can get it from.
Well, Mark, it's been great to speak with you today, but just before we finish, is there any word on Stargazing Live in 2014 yet?
All I can say is that it has been recommissioned. So it will be coming back. I can't tell you anything about dates yet because that's all being discussed. But yes, it will be coming back. Watch this space. Follow me on Twitter, of course. And as soon as I know anything, I'll put it out there for you.
Well, Stargazing Live, that's one of the big TV events in the astronomical calendar, so we'll all look forward to that. Mark Thompson, thanks for speaking with us on Awesome Astronomy.
It's been a pleasure.
This is Awesome Astronomy.
Okay, and now it's time for our favourite part of the show, the bit where you good people out there set the agenda. It's time for questions and answers. Now, our first question is from a John Wildred in London via the Facebook group. Dear sirs, following the recent impact on the moon, will we be able to see a new crater? If not, how big would the impact object need to be to create a crater a few kilometres wide? Ralph.
He called us sir. Now that's what I like. A little bit of respect. We deserve a bit of respect, don't we?
Yeah, I think so. I think so. They will learn.
Well, if I'm understanding you right, John, I think you're referring to the bright meteor strike that hit the Mare Imbrium on the moon on the 17th of March this year. And if so, that's thought to be a half-metre wide chunk of space debris from the Gamma Normin meteor shower that, rather than burning up in the Earth's atmosphere, hit the side of the moon that was in darkness. And that allowed anyone that was viewing that night's beautiful lunar phase to see a magnitude 4 explosion that lasted for about a second. But unfortunately, you're not going to be able to see the crater it left behind with Earth-based telescopes, as the crater will only be about 20 metres wide. Though actually that's within the resolution of the Lunar Reconnaissance Orbiter that's been snapping images of Apollo descent modules and the foot trails that were left by the 12 Apollo moonwalkers. So that'll try and capture this new crater when it passes over that part of the Mare Imbrium. But to see a new crater on the moon, even if you had, say, a large 12-inch Dobsonian or slightly larger scope, you'd need a meteor to punch a crater in the region of 2 to 4 kilometres wide, and for that, you'd have to take a few things into account. Well, there's no atmosphere on the moon worth talking of, so you don't have to worry about how much of a meteor gets burned up before it hits the lunar surface. But the other variables that affect Earthbound meteors are still going to apply, and they are, firstly, the density of the meteor, because a predominantly iron meteor will pack more of a punch than a rocky one. Then there's how fast the meteor's travelling, because this dumps more kinetic energy into the ground and affects how big the crater would be. And of course, how big the meteor is itself. So it's actually difficult to say how big an object would need to be in order to make a crater visible to Earth, as an iron football travelling at 30 miles a second could do the same damage to the lunar surface as a slower travelling but larger rocky impactor. So I took a representative sample of lunar impactors and the size of the craters that they left behind, and based on these, I'd say, with a whole bunch of caveats, that you'd need a 50 to 100 metre wide asteroid impact as a minimum to be able to carve out a 2 to 4 kilometre wide crater that would be visible from Earth using a large aperture amatoscope.
Okay, so there we are. Our next question is from Michael Shaw, again via the Facebook group.
And Michael asks, after reading various books on the possible outcome of the end of the universe, it made me think, if we have star-forming regions that are creating new stars from clouds of gases, are the gases created from supernovas? If so, wouldn't the universe continue on forever in this death and rebirth cycle? Not astronomy, but I hope you could shed some light on it for me, however brief. Well, I think that is astronomy and cosmology, and good luck with that one.
Oh, yeah, definitely. Right, here we go. Right. Well, what Michael is alluding to is the heat death of the universe. Now, of course, this always carries the caveat of theory. There are alternative endings predicted, but this one is considered the most likely with our current understanding of physics and the universe. The heat death is a future where the universe never ends, it just cools and becomes a dark, matterless void. Cheery thought.
Cheery.
Yeah, very cheery. So how come the stars don't just keep recycling? Well, what you're going to come up against is entropy, or the second law of thermodynamics, and in coming up against the second law, you are not going to win. The astronomer Arthur Eddington puts it this way in 1927. The law that entropy always increases holds, I think, the supreme position amongst the laws of nature. If someone points out to you that your pet theory of the universe is in disagreement with Maxwell's equations, then so much the worse for Maxwell's equations. If it is found to be contradicted by observation, well, these experimentalists do bungle things sometimes. But if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation.
That's an awesome quote.
It's brilliant, isn't it? Arthur Eddington. So, what is entropy? Put simply, it is the idea that a system will always move towards thermal equilibrium. That within a closed system, and the universe is perhaps the ultimate closed system, things will end up at the same temperature. Okay, so what? My cup of coffee ends up at room temperature and needs to be reheated. Well, reheating takes work. You have to gather energy from somewhere, in this case microwaves, to put energy back into the cup of coffee, which at present, in our everyday existence, is no problem. But every time I reheat my coffee, the entropy increases, and the particles that make up your coffee laugh at the order you try to impose on them and do their best to once again be in thermal equilibrium with their surroundings. Your coffee goes cold again. For coffee, read stars. For our microwave oven, read the available energy in the universe. If our microwave has a finite amount of energy available to it, eventually we'd no longer be able to reheat our poor abused caffeine hit. And so it is with the universe. I'm going to bring in another law here, the law of conservation of energy. Energy is everything. It is neither destroyed nor created, it just moves around. There's a finite amount of energy in the universe, and where it is at present tells us what sort of universe we live in. Right now, a lot of energy is tied up in stars, planets, computers, coal, rubber bands, and small dogs. I will just say the words dark energy to satisfy the pedants, and then move on. There is also dark energy. Anyway, as Einstein showed in E equals mc squared, energy and mass are equivalent, and two sides of the same coin. But this energy doesn't stay where it is, it wants to be in equilibrium across the system, and it gets spread around. The heat of your coffee leaks into the air around you. Stars send their light and heat into the universe. Entropy is thought to be why time's arrow points only one way. Your body fights entropy, expending energy to work against the universe, but we all lose that battle, and so do stars, and every time a new generation of stars is born, more of that energy is spread into the ever-increasing thermal equilibrium of the universe. To put it another way, the amount of energy put into making a star is not the same amount left over at the end of a supernova. And so there is always less and less potential energy to work with. The universe cools, and once equilibrium is achieved, work is impossible, as work requires a temperature difference to be present in order that energy moves. So I hope that answers your question. Our last question is from Scott Ford Wally via Twitter. What would you say are the top 5 objects in the night sky to view with a telescope? Tough question. Top trumps?
Okay, you start.
Okay. The sun. I'm going to say the sun. It's the closest star. That's got to be a good call. Granulation, prominences, sunspots.
Okay, I'll see you, your sun, and I'll raise you the moon.
Ooh.
It's close enough to observe. You can see a lot more detail on it than you can on the sun.
Yeah, you don't need special filters.
You don't need special and expensive equipment.
No.
And we've actually been to the moon.
Yeah, that trumps. I'll go with that. Go on, okay.
Okay, my second one, I'm going with Mars.
Okay.
I'm going with Mars because it's one of those planets that you get a real feeling, even though it's very small, its size in the sky when you're looking at it at a favourable opposition can get anywhere as high as about 25 arc seconds. But you still get an impression, even though it's still quite small, much smaller than Jupiter, that it is really a solar system neighbour. And you can see, rather than seeing the tops of clouds, you actually see planetary detail. You can see polar caps, and you can see the planes.
And a big scope, you start to see mountains, and you can get those hints of, that's a good call, okay.
So, what are you going with?
Okay, I'll see your Mars, and I'll raise you a Saturn.
Ooh, good shout.
I don't even have to explain it, do I?
No, you've got to.
I mean, the rings, just the rings. It's stunning. The rings. I mean,
I'll give you Saturn.
Every time I have shown, last night, I was showing probably half a dozen people Saturn for the first time, and I think every single person put their eye to the eyepiece and said, "Oh my god!"
Yeah, you've got Saturn.
Yeah. Okay. Michael. Double cluster.
Good one.
Double cluster.
I'll pit against that one Epsilon Lyrae.
Ooh.
The only double star where when you split them, the stars remain as far away from one another.
And the double cluster, you can see naked eye, just as a smudgy patch.
But I think that's
in a dark
good,
sky. But that's great.
I wouldn't say that was a negative.
Yeah, no, it's not a negative, but I think I like Epsilon Lyrae because you have to work at it. You have to work the magnification, and then you get that surprise.
Although there's a nice little cheat. If you've got a medium-sized scope and you use a zoom eyepiece, you can see them as a single star, then as a double star, and then as four stars, just by rotating your eyepiece.
Yeah, it's such a great object. Right, you're cool.
Oh, you've given me Epsilon Lyrae, have you?
I'll give you that one.
I'll give you that one. I think I'm going to get the next one as well. I'm going to go with Albireo.
Ooh. Little blue and yellow gem. Oh, that's stunning.
Okay, so what are you going to pit against Albireo?
M13. The Great Globular Cluster.
As we heard earlier, lots of people like that from Astro Camp.
It's just stunning. A little fuzzy ball of stars, and as you get closer and you rack up the magnification, you start to see more. It's stunning.
Like a galaxy.
It's a little miniature universe almost. It's just beautiful.
Okay, well, I'm going to play the disability card here. As a man with daltonism, 1 in 10 men are colourblind. But even if you're colourblind, unless you're completely colourblind and you only see things in black and white, you can still pick out beautiful yellow and a really rich azure blue star in Albireo when you split them. And there aren't many star clusters where you can actually pick out anything other than something that just looks white or slightly yellow.
Yeah, that's true. Okay, we'll might call that one a draw.
Okay then, finally, what are you going with?
I'm going to go with Bode's Nebula, M8182.
Okay, well I think you're cheating there because you're trying to get 2 galaxies in one.
But they are one. You can't view one without the other.
In that case then, I'm going to try and sneak 2 galaxies in for one, and I'm going with M51, the Whirlpool Galaxy.
Oh, yeah, that is 2. That is 2.
And how many galaxies out there can you see in an amateur scope where you're watching one galaxy devouring another one that got too close to it?
It's stunning, and I mean they're both stunning objects. I mean, 8182, you're seeing 2 galaxies gravitationally interacting. You're seeing that the starburst, all that star formation going on. I mean that's beautiful. M51. That's really stunning.
Does that mean you're conceding it?
Oh, I don't know. Maybe another draw?
Go on then.
We're going to need a thumb wrestle at this rate.
So who won that one then?
I think we drew.
Did we draw?
And then I think you won. I think you won.
Winner! Winner!
Man.
This is Awesome Astronomy.
Well, that just about wraps it up for this month. If you want to come along to the friendliest and most fun star party around, then we're holding the next Astro Camp in early September. You can find out more, book your place by visiting www.astrocamp.org.uk. Please do continue to send your astronomy questions to us via Twitter at AwesomeAstropod, or the Facebook group, which you can find by typing Awesome Astronomy into the Facebook search bar, where you'll also find tons of images and great astronomy discussions from our listeners. Also, if you have any friends that use Android devices, you can tell them that the IPP podcast player will let them listen to the show too. And finally, if like us you prefer style over substance and use Apple products, please do give us a review on iTunes and make sure you subscribe to the show. Both place us higher in the podcast listing so we can spread the astronomy awesomeness wider and further. So that's all for this month. We'll be back on the 1st of July, so it's goodbye from Cydonia Base.
Awesome Astronomy is produced by Ralph Wilkins and Paul Hill, and is free to distribute for educational purposes. Music is courtesy of Star Salzman. For more information about this podcast, visit our website at www.awesomeastronomy.com. You can join in the astronomy discussion in our Facebook group, which you can find by typing Awesome Astronomy into the Facebook search bar, and you can follow us on Twitter at AwesomeAstropod. We invite your questions to read out on the show. You can send them to us through our website, Facebook group, or Twitter. If you have any comments for the show, you can email them to us direct at inbox@awesomeastronomy.com. We thank you very much for downloading this podcast and for listening. From Cydonia Base, end of transmission.
But if your theory is found to be against the second law of the lobster thermidor, the end.